In Chapter 9, we'll be learning the fundamentals of probability, using things like set theory, Venn diagrams, things like union and intersection that we covered back in Chapter 2 to help us with understanding the various complexities within the subject. Our book defines probabilities as ratios that can be determined considering the outcomes of an experiment. Now, an experiment in as far as probability is concerned would be trying to do something like drawing from a deck of cards, flipping coins, rolling dice, and having a particular set of conditions that we are trying to analyze. Where the set of all possible outcomes is often referred to as the sample space. And the packet that I'm using in all my videos for the semester, you can find on this Canvas page, usually at the top. And what I recommend doing is printing it out and following along and working it out as I go to sort of test yourself and see if things are making sense. While a subset of the sample space is often referred to as a probability event, where an event is like something where, like, say for example, rolling a die. You could say rolling a 1 or 2 as an event, and that would have a particular probability given, assuming that the dice or the die had 6 sides. So let's just practice doing a few things, practicing writing out sample spaces and looking at different events that could occur. The sample space, the book often uses S to describe this, but basically we're going to use mathematical set notation. Let's just say S will be the first described event, or sample space, which would be all of the outcomes for rolling a 6-sided die. So if you roll a 6-sided die, there are 6 outcomes, right? You could either get a 1, 2, 3, 4, 5, or 6. So we could use, mathematical notation to write, well, what are the potential things that we could roll from this die, 1 through 6, and that would describe our sample space. Basically, every possibility that could happen. Or say we were talking about flipping a coin, I'll just write that as C. We'll just call C arbitrarily for standing for our sample space for the coin flip. And that consists of 2 outcomes, right? Either heads or tails. And you could list it all out as heads, comma, tails, or just H and T for short. Obviously, we use shorthand a lot of times so that we don't have to write out as much, especially for more elaborate experiments. But you obviously want to know what it stands for. And in the case that you might, let's say you have 2 different words that start with H, you might want to pick something else or a different way of a different naming or numbering convention for that sample space. Now, events, as I described, could be usually are subsets or proper subsets of the original. Technically, you could say, well, an event could be the full subset, like just the entire event, but usually that's not very interesting. So say, for example, we were talking about the event. Let's just call A one random event. The outcomes of rolling, let's just say a 4 or less or something at random. So that would consist of, well, 1, 2, 3, or 4, right? And the unacceptable outcomes would be 5 or 6, not rolling 4 or less. And basically, again, we'd have a subset of the larger set, the sample space. And with probability, it is often helpful to analyze, well, what are all of your potential outcomes which are satisfactory? A lot of problems that you're going to be facing in this chapter are going to be written out like a word sentence describing a particular situation. And it's critical that you can take that and figure out and write out the event set and the sample space, because it'll be critical for finding the probability. Or we could say what's another event involving the dice, the rolling of the die, which would be saying, let's say we get an even result, 2, 4, or 6 would be acceptable outcomes, and the subsets could be any combination of sizes. Or for events for flipping a coin, you don't have as many options because there's only 2 elements. You could either flip a heads or a tails. Technically, you might think, well, could it be both or could it be nothing? And that's kind of dependent on the situation. But you could say, well, either result is acceptable. That would be, let's just say D is sample space pertaining to the coin flip. You could have HT, like the full subset B, exactly the same as the sample space, just not very meaningful because basically you're saying any outcome is acceptable. Or you could have the empty set as your event space, which means there is no acceptable outcome. But usually we don't really look for those because those are not very interesting. We tend to look for actual events that are proper subsets to the original set.